Hello everybody, today we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadiko's 5th edition. The question number is 19.29 and the question is find V1 and V2 using Y parameters. Confirm the results in part A by direct circuit analysis. In this video we are going to solve only the A part. We'll see the B part later in some other video. Okay, and we have a bridge network. Since we are asked to solve this problem using Y parameters, we prefer only the pi network. This is a T network which is shown here with the help of this green color. 3 ohm, 3 ohm and 3 ohm resistors. These form the pi network or the delta network. Okay. So the other name for delta network is pi network, and the other name for this T network star T and then Y. As we prefer only pi network for this Y parameter, we are going to convert this T network into pi network. For our convenience, I have shown this T network like this Y network, and we have to convert this Y network to delta or the pi network, right? So I have joined the nodes of this, that is A, B, C, along with this RA, RB, RC, which would form the arms of this delta network. So we know actually how to convert this T into delta. Just the formula is sufficient, so we know that this formed RA resistance can be found out using this formula R1 R2 plus R2 R3 plus R3 R1 divided by R1. Okay, so we have to consider any ohm as R1. Otherwise we'll actually mention the name of the resistances like R2 and R3. So the node which joins the R1 can be taken here as A, and this R2 can be taken as B, and this R3 can be taken as C. So in between A and B, we'll be having this RC, which is actually opposite to this R3. Like that, we have to frame this structure, okay, because we are not given any particular name for this. Similarly, the opposite to this R1 arm will be having this RA resistance, and to the opposite of this R2 resistance we have this RB. So in that way we have to form the structure. Later on, with the help of the formula, we can find out the values of RA, RB and RC. We start with this RA. So what is the value of R1, R2? There is the product, right? So it is 3 into 3 plus R2 R3 is 3 into 1 plus this R3 R1 is 1 into 3 divided by this R1 value is 3. So we get this as 9 plus 3 divided by 3, that is equal to 15 by 3. So we get the answer as 5 ohms for this RA. So in place of RA you can substitute the value as 5 ohm. Then we move on to find out this RB value. So how to find out this RB value? The formula is given here. So in the numerator, we'll get the same value, right? So it is 15. In the denominator, we have to substitute this R2 value, that is nothing but 3. So again, we'll get the 5 ohms for this RB resistance. So in place of this RB, we'll substitute this 5 ohm. And then we move on to find out this RC value. So RC value is also in the numerator, you get it as 15. To the denominator, we have to substitute this R3 value. So R3 value is 1 ohms. So we get the answer as 15 ohms for this RC. So substitute that RC value here. So we got this delta network. Now in place of this T network or the star network, we can place this delta network. Okay. So this is our T network. Now we are going to replace this with the help of this delta network. So, but actually we want the pi shape, right? So this is a single node C. It can be actually widened here so that you will get the shape of the pipe. So A to C you have this RB, B to C you have this RA, and between A and B we have this RC value. So we got this pi network. In order to analyze the circuit using Y parameters, we need to have only one pi network. And above this RC you have another 3 ohm resistance. So this 3 ohm and this 15 ohm or the RC, they are in parallel, right? So we have to actually find the equivalent for these two. So how to find out the equivalent of this parallel resistors? It is 3 into 15 divided by 3 plus 15. So we get it as 45 by 18. It is 2.5 ohm resistance value. Okay. So now I am going to replace these two values by 2.5 ohms. So we get the single pi network. So in the problem we have given this I1 value and I2 values. I1 is 10 amps and I2 is minus 4 amps. As we want to analyze this circuit using Y parameters, the resistor values 5 ohms, 2.5 ohms and 5 ohms, that must be converted into admittance. So how do you convert this resistance into admittance? It is just by taking the inverse. So this 1 by 5 is the inverse of the 5 resistance, right? 5 is the 5 ohm resistance. It is the resistance value. So if you put 1 by 5, that becomes more, and it is the admittance value. Similarly, already we have this 2.5 ohm resistance. 2.5 can be written as 5 by 2, isn't it? So it is the resistor value. So to get the inverse, we get it as 2 by 5 more. Here also we have 5 ohm resistance earlier. Now it is converted as 1 by 5 more value. After getting this pi network, we have to actually find the value of this y parameters just for getting the y parameters. Okay, how would you get this y parameter? So whatever value present here, that is this 2 by 5 ohm is nothing but minus y12, that is the transfer admittance, right? It is also equal to minus y21, and the value which is available at this end, 1 by 5 more, that represents y22 plus y12 value. At the input side, you have this 1 by 5 more, that represents y11 plus y12. So you should know this. That's the concept for understanding. Okay. From that, we can actually find out the value of y11, y22, y12 values, like that. You can get the y parameter values. So already from this, we come to know that it is minus 2 by 5 more for this y12. And for y11 plus y12, we get this 1 by 5 value. So that what is the value of this y11? It is 3 by 5 more, isn't it? Because here in place of this plus y12, you have to put it as or substitute it as minus 2 by 5. So you get the answer as y11. Similarly, on this side, you have this y22 plus y12. So in place of y12, you can substitute it as minus 2 by 5. So that y22 is also 3 by 5 more. So we got the y parameter values. Now we move on to solve the same problem using KCL. So after getting this modified circuit, we are going to solve this using Kirchhoff's current law, isn't it? So we mark this as node 1 and this is marked as node 2. First we'll mark the remaining currents also. We know that this is the I1 current which is supplied by this current source, and this is entering into this node 1. And similarly, this I2 current is also given here in the problem itself, but we need to mark the remaining currents. So from the node 1, we can mark the downward current as I3, and the current which is flowing right side, that can be marked as I4 by us, and the downward current from the second node can be marked as I5. So for our convenience, just we have marked all these currents. Okay, that is I3, I4 and I5 are the currents marked by us. And the node potentials at 1 and 2, they can be taken as V1 and V2. So now we are going to apply KCL at node 1. So what are the incoming currents? I1 is the incoming current, and what are the outgoing currents or the leaving currents? I3 and I4. For this we are going to apply Ohm's law now. So I1 current value is already given, so it is substituted here. In place of this I3, we can write it as, it is V1 minus this, that is this potential, that is the I3 current is flowing from node 1 to this ground node, isn't it? So it can be written as V1 minus the 0 potential divided by that admittance, actually divided by that resistance. Here we have the admittance, so we have to multiply it. Okay, so V1 minus 0 multiplied by this admittance value, and then we have this I4. So in place of I4, you can write it as V1 minus V2 multiplied by this admittance 2 by 5. So we can actually rewrite this as V1 by 5 plus this can be written as V1 divided by 5 into 2, that is 2V1 by 5 minus 2V2 by 5. So from this we can write this as 3V1 by 5 minus 2V2 by 5. When you multiply all these equations by 5, we get this as 50. Then this 5 and 5 get cancelled out, so you get this as 3v1. Here also 5 and 5 get cancelled, so you get this as minus 2v2. So we got the first equation. In a similar way, we proceed at the node 2 by applying KCL. So in this we have two currents are entering into this node, that is this I2 current is entering, similarly I4 current is also entering. This I5 is the leaving current. So we can write the KCL as I2 plus I4, that is the incoming currents, sum of the incoming currents, that is equal to the leaving current I5. To this we apply Ohm's law. So I2 current we know that it is minus 4, and in place of I4 you can write it as this V1 minus this V2 multiplied by 2 by 5 admittance. That is equal to this I5. I5 is V2 minus the 0 potential multiplied by 1 by 5, that is that admittance. So it is minus 4 plus 2V1 by 5 minus 2V2 by 5, that is equal to V2 by 5. So we get this as 20, that is equal to 2v1 minus 3v2. That is when you multiply this equation by 5, you will get it like this, second equation. Okay, so we write these two equations together, first equation and the second equation. Now multiply the first equation by 3, so that you get it as 150, that is equal to 9v1 minus 6v2. We take it as one first equation prime, or the modified form of this first equation. Then multiply the second equation by 2, we get it as 40, that is equal to 4v1 minus 6v2. So we take this as 2 prime. We are going to solve this by subtracting this second prime from the first prime. So this 6v2 and 6v2 get cancelled, and here you get this as 110, that is equal to 5v1. So v1 is equal to 110 by 5, that is equal to 22 volts. So we got the first answer, that is v1 is equal to 22 volts. Now we substitute this v1 value into the first equation. So that is okay. Let's substitute this v1 value into the second equation, so that it can be modified as 20 is equal to 2 into this 22 minus 3v2. So 20 is equal to 44 minus 3v2, or 3v2 is equal to 44 minus 20. So v2 is equal to 24 by 3. So that is equal to 8 volts. So we got the answers as v1 is equal to 22 volts and v2 as 8 volts. Okay, thank you. Hope you have understood this